So in thermodynamics, we mainly concentrated on system and surrounding. So first of all, what is a system? So system means, suppose if you take a part in which our interest process, the area where the process takes place is called as a system, and the system is separated with the surroundings with the boundary. This boundary may be a fixed boundary or an imaginary boundary. So this is the system, and it exchanges energy and mass to the surroundings. It exchanges energy as heat or the work. And now the various forms of energy are, you know that it is an electrical energy or the mechanical energy or chemical energy or internal energy. But the mainly here we'll discuss only the two forms of energy, that is the macroscopic form of energy and macroscopic form and microscopic form of energy. So these two, this macroscopic and microscopic, it constitute the energy of the system, whereas the energy of the surroundings is represented with work and heat. And now, so first we move to the microscopic, the form of energy. So what is the macroscopic, the form of energy? So in the microscopic form of energy, the energy can be measured with the macroscopic variables. Suppose if we take the kinetic energy, the kinetic energy is measured with the motion, right? So kinetic energy comes under the macroscopic form. And similarly, if a body falls from a height, then by gravity it will falls down. So this kinetic energy and potential energy, these two comes under the macroscopic forms of energy. So we can easily measure with the help of the macroscopic variables, measuring variables. But the microscopic form means it is the matter consists of various molecules. So we cannot. So every the molecule has some energy. That is, some energy is internally stored. So that type of energy is called as the internal energy. So therefore, the system energy is this macroscopic and microscopic. So the kinetic energy plus potential energy plus internal energy. Now we will discuss what is a kinetic energy in detail. So first, the kinetic energy. The kinetic energy, so let us consider a body of mass which acts upon a force F, and it travels a distance dl during a time interval, the dt. And we know that as the work done is force into displacement. So dw equals to force into displacement. According to the Newton's second law of motion, force equals to mass into acceleration. So now here dw equals to ma into dl. So where acceleration due to gravity, it can be represented in terms of velocity also. So that is du by dt into dl, or m dl by dt into du. And this dl by dt, this is nothing but velocity, and it is represented by the symbol u. So therefore dw equals to mass into velocity into du. If you integrate this equation, having initial velocity u1 to a final velocity u2, then the resultant equation will be m u1 to u2 u du. So it is m u2 square minus u1 square by 2, or m delta u square by 2. So this term is called as the kinetic energy. And this term was introduced by the Kelvin in 1856. And coming to the units of these internal kinetic energy is the mass. Generally the mass units are kg, and the velocity units meter per the second, so squares. So kg meter square per second square, or Newton the meter, or joules. So these are the units for the kinetic energy. And now coming to the kinetic energy is defined as the energy possessed by a body by virtue of its motion. So movement is there. So velocity means it is moving. So kinetic energy is defined as the energy possessed by a body by virtue of its motion. Now coming to the